Hello, welcome to another video by Emily Learning. In this video, we'll be looking at what you need to know for kinematics as tested in O-level physics. So let's get started. The best way to find out what you need to know for a particular chapter for your exam is to look at the syllabus. So in this slide here, you'll be seeing the syllabus, the O-level physics syllabus. Okay, so this is on the topic kinematics. So let's take a look at what you need to know for this chapter. Okay, so let's look at it line by line. So in part A, you need to state what is meant by speed and velocity. So in other words, you need to know the definition of both speed and velocity. I do have a post on the list of the common definitions that you need to know for O-level physics. So I'll provide a link below so that it's easy for you when you're studying or you're memorizing the definitions. Okay, so basically what you need to know for part A, the definitions of speed and velocity. So what is speed? So speed is distance traveled over time taken. Okay, or the rate of change of distance traveled with time. Okay, then velocity is the rate of change of displacement with time. Okay, speed and velocity both have a units of meter per second, but the difference between speed and velocity is that speed is a scalar quantity. So being a scalar quantity, we only look at its magnitude. Okay, but for velocity, it is a vector quantity. So it has both magnitude and direction. So we need to look at both the direction as well as the magnitude when we are talking about velocity. Okay. Next, we look at average speed. So average speed is basically the total distance traveled divided by total time taken. So for most of the things, right, for most objects, they do not move at the same speed all the time. Okay, so we can look at its speed at a particular point in time, which we call instantaneous speed. We can also look at an average over a period of time, which we call average speed. So to find average speed, what you need to do is to find the total length traveled by the object and divide it by the total time taken. Okay. Next, we look at part C, state what is meant by uniform acceleration and calculate the value of acceleration using change in velocity over time. So what is meant by uniform acceleration? So when acceleration is uniform, it means that the rate of change of velocity with time remains constant. Okay. Next, you need to be able to calculate acceleration. So you do need to know the formula for acceleration. And we know that acceleration, which I denoted as A, is equals to the change in velocity. So it's equals to final velocity V minus initial velocity U over time taken T. Okay, so this is one of the formulas that you need to know for your physics. I also have another post on uh, a list of the formulas that you need to know for your O-level physics. So if you are interested to find out what are the formulas that you need to know, do check out our post. I'll provide a link in the description below. Okay, so you need to know the formula for acceleration because you will be asked to calculate what is the acceleration. Okay. Next, you will need to be able to interpret given examples of non-uniform acceleration. Okay, so usually they will give you a scenario or give you a diagram and you'll need to be able to interpret whether the acceleration is uniform or not. Okay. Then part E, you'll need to plot and interpret displacement time graph and velocity time graph. So basically, right, if I look at part D all the way to part H, okay, it is basically being able to interpret the displacement time graph as well as the velocity time graph. So if I were to call displacement S and time T, okay, so when I have a displacement time graph, okay, apart from being able to tell the displacement at a particular time, or uh, yeah, the displacement at a particular time, there are other information which I can get from this displacement time graph. Okay, so for instance, the gradient, right? Okay, so the gradient of a displacement time graph will give us velocity. Okay, so if I were to look at this is a straight line. So what does it suggest? Well, it suggests that the velocity is constant because for a straight line, we have a constant gradient. Okay, so I know that the velocity is constant for this portion. Okay, then at this position here, there is no change in displacement. That means the object is always moving, is always at a certain point, right? So if it's always at a certain point, what does it suggest? It means that the object is not moving at all. Okay, so when it is a horizontal, when the graph is horizontal, it means that the object is not moving. All right. Okay, and what is the gradient of a horizontal line? It is equals to 0. So this suggests that the object is at rest because the velocity is 0. Then we have this line going down. So it's a straight line, so the velocity remains constant. Okay, then we have a curve here, meaning that the velocity is not constant. And because the gradient of the curve is getting steeper, we know that it is moving with increasing velocity. All right. So this is a displacement time graph. So from a displacement time graph, apart from being able to tell displacement, we can also tell velocity. Okay, because gradient of the graph is equals to velocity. All right, so next, what I'll do is I'll erase this away and we will talk about another type of graph. Okay, so I've talked about displacement time graph. Next, I want to talk about velocity time graph. So I will call velocity V and time T. Okay, so let's plot a VT graph. Okay, so let me draw it this way. Okay, so from a velocity time graph, basically because I have V in the y-axis and T in the x-axis, so what it tells me is definitely I'll be able to tell the velocity um, at a particular time, right? So I just need to read off the graph. But there are additional information that we can get from a velocity time graph. The first being that the gradient of a velocity time graph is equals to acceleration. Okay, so if you look at this straight line here, so a straight line have a constant gradient. So because I know that the gradient is constant here, I know that acceleration is constant here. Gradient is equals to 0 at this horizontal portion. That means acceleration is equals to 0 here. Okay, but when acceleration is 0, the object is still moving. It is just that it is moving at constant velocity. Okay, then velocity decreases, right? What can I say about this? Well, I can say that acceleration or the object is decelerating uniformly, okay, because it is a straight line. Okay, then I have a curve here. So what does a curve suggest? Well, a curve tells us the um, acceleration, right? So if I look at from here, this point here to this point here, I know that the gradient is decreasing until it reaches 0. Okay, so in other words, from here to here, the object is moving with decreasing velocity, with decreasing acceleration. Okay, now from here to here, it is decelerating because the velocity is decreasing. Okay, and gradient is also negative. When gradient is negative, we say that it is decelerating. Okay, so now what can I say about here? Well, I know that it is moving with increasing deceleration because the gradient gets steeper, right? It becomes more negative, but it becomes steeper. So I know that it is moving with increasing deceleration. All right. Okay, so let me summarize. So for a velocity time graph, we apart from being able to tell velocity at each particular time, we can also tell the acceleration. So acceleration is given by the gradient of the graph. In addition, we can also find the distance traveled. Okay, so how do we find distance traveled? Well, the area under the graph will give us the distance traveled. Okay, so by finding the area of the graph, we'll find the distance traveled. Okay, so this is what you need to know for the displacement time graph as well as the velocity time graph. I would suggest that when you're doing a revision, okay, take a sample of a velocity time graph. There will be many in your 10-year series or in your worksheets or your school's notes, right? So take a look, make sure that you know that how. So if you look at the displacement time graph, look for a position, look at points where the body is at rest, okay, moving with uniform the velocity and moving with non-uniform velocity. And do the same for the velocity time graph. All right. So now that we have covered this, let's look at what else do we need to know for the chapter on kinematics. Well, we need to state that the acceleration of free fall for a body near to Earth is constant, okay? And it is approximately 10 meter per second square. So what this means is that, right, if I throw an object down, okay, in the absence of all other forces, including air resistance, it will be accelerating uniformly at 10 meter per second square. Similarly, if I were to throw an object up, okay, and I'm on Earth, in the absence of all other forces, okay, except for gravity, its deceleration would be 10 meter per second square. So if I'm dropping something, the A acceleration is equals to 10 meter per second square. If I'm throwing something upwards, okay, gravity is pointing, weight is pointing downwards, right? Because it's moving in the direction opposite to weight. Okay, so it will be decelerating. So deceleration is negative acceleration. So when it's moving up, the deceleration is equals to 10 meter per second square, or the acceleration is equals to negative 10 meter per second square. So this is what part I is trying to tell us. Lastly, in part J, you need to describe the motion of bodies with constant weight falling with or without air resistance, including reference to terminal velocity. Okay, so you need to be able to explain what is happening when we are throwing an object downwards. Okay, so let's look at without air resistance first. So without air resistance, the only force acting on that object is weight. Okay, and the mass of the object always remains the same, right? So W equals to mg. If m is constant, okay, W will also be constant. G will also be constant. So in other words, right, this means that the acceleration on this object will be a constant. So in the absence of air resistance, the object would fall with a constant acceleration of 10 meter per second square. Now, if there is air resistance, and I'll call air resistance R, okay? Then there will be two forces acting on an object, W and R, and they are acting in opposite direction. So the resultant force is equals to W minus R. Okay, so the value of the air resistance is related to its velocity. So the faster an object is, the higher the air resistance. The slower it is, the lower the air resistance. So initially, air resistance is low, right? Okay, because it's if I allow the object to fall freely, its speed will start from zero. So when the speed is zero, the air resistance is zero. Then it accelerates downwards, right? Okay, so the speed increases, so will air resistance. Okay, so as the object moves downwards with increasing speed, the air resistance increases, right? So when air resistance increases, resultant force will decrease, and it will decrease until the point where the it will decrease at the point till W is equal. So what happens when W is equals to R? Well, when W is equals to R, this is what happens. The resultant force is equals to zero. Okay, when the resultant force is equals to zero, there will be no net force acting on an object. And when there is no net force acting on an object, this one you'll learn more in this chapter on dynamics. So when there's no net force acting on an object, it will move at constant velocity. So in other words, right, in short, what it means is that it will now move at constant velocity. So in other words, you have reached the maximum velocity already. It can no longer increase anymore. Okay, and when that occurs, we say that it has reached terminal velocity. Okay, so at this point here, it is when it has reached maximum velocity. Okay, and W is equals to R. Okay, so you need to be able to explain what happens when an object is moving with the presence of air resistance. All right, and you need to know what is terminal velocity. It's basically the maximum velocity reached when an object is allowed to fall freely and its weight is now equals to the air resistance. So there's no resultant force acting on it. All right. So we have come to the end of the what you need to know for the chapter on kinematics. So do check out our videos on the what you need to know for the other chapters.